Good morning, everybody. I'm Matt Sump. I got Max and Pete with me here today. They'll be doing most of the show.
Pete Kuchtra is here with me from Re3D Tech. We're here at the ShopWare office in Elgin, Illinois. Matt, thank you for opening us up and some of the coordination here. The purpose of today and the agenda, if you will, is to talk about where service bureaus fit into the 3D printing world. And one of the first questions you might ask yourself, whether you work at a plastics house, a foundry, a CNC shop, fab shop, or job shop, is does 3D printing fit into what we're doing? And there's a technical box to check there, and there's also a commercial box to check. So for instance, will my parts last in the application that I have in mind? And secondly, does it even make sense for us to have a printer in-house? Will the printer pay for itself in a given period of time and make my boss happy and make me look good for the decisions we made to either 3D print or buy a printer? There is so truth be told, an inflection point of where it makes a lot of sense to use a service bureau for 3D printing needs. And that's the reason why we're here today. We're going to take a step back and talk a little bit about current manufacturing processes, current state, and what are some typical processes today. The commonality between what we have on our screen right now is essentially the fixed costs of durable tooling are expensive, and I'm sure we're all aware of that. And so what you have in the process of designing and ending up to the final part is a multitude of steps. Sometimes these steps for making tooling, if you will interrupt a CNC or lathe or the machine shop time where it's non-billable parts. And so you're making tooling where otherwise that CNC could be making or working on a current work order that you'll be shipping and invoicing. And that's what pays the bills. So here is a list of 9 steps we're all familiar with in the process of coming up with the final part. That could be a fixture, it could be work holding, it could be soft jaws, it could be parts that go in a cope and a drag for sand casting, and or a CMM fixture in our case. And the concept, lay of the land, if you will, of making that decision to 3D print or not, and whether or not to use a service bureau or your own 3D printer is outlined in what we have, sorry about that, and what we have here. And so for every use case, again, there's an inflection point of where it makes sense, economies of scale, to utilize this technology, 3D printing, given that in the application, these parts will be within tolerance, they'll have the right surface finish, and other attributes like that. And so when Pete or I start to talk to customers, and early on in the conversation about 3D printing, we like to understand what problem we're solving and what your current state might look like in the future if additive or 3D printing is adopted. And so in the background, there's a kind of a conversation that we'll have concurrently with you about the commercial aspects of it. And I think this chart kind of summarizes where you need to be or not need to be to have it make sense. The takeaway from this slide and the slide after it is really to set the stage for where is this applicable or where is it not, because 3D printing isn't always the best fit. And so there's a little bit of qualification of application involved. But if you look back in time a few years, or even 5 or 10, 15 years, you'll see a lot of design and prototype applications. And so if we're talking about FDM printing, for example, forcing a plastic matrix through a hot nozzle at a given layer width, layer height, ABS, PLA, common materials for designing prototypes. That's what it's been like. With Markforged and the software that they've developed with their materials and their hardware, and because the Onyx material has 20% chopped carbon fiber in the material, we're now able to talk about tooling, production, assembly, sometimes end-use parts. It really depends on the use case, the application, the ambient temperature if the part's outside, the heat, and if it's going through going through too much stress or impact and things like that. So where we're at today compared to a few years ago has widened the potential applications. With that said, I'm going to turn it over to Pete from Reedy Tech, and I'm excited to see the information that he has to share with us this morning.
Yeah, thank you, Max, and thank you everyone that joined in today. Pretty excited to kind of show you some of the stuff that we have on our end. We've been fortunate to work with Max for a few years now, actually, and we've had a really good relationship. And one of the questions you might be asking yourself is, how does a service bureau and actually a customer of the Markforged technology fit into doing a webinar with someone that actually just sells the printers? Based on that perspective, you would think that we'd want to just sell you parts, but the reality is a lot of our customers actually own Markforged technology and are well into the 3D printing kind of road trip that they tend to go on. So we embrace letting our customers kind of bring in their own technology. In many cases, we act as their overflow point for when they need kind of some volume printing, as well as a good turning point for specific applications that we might be able to help them on. So to give you some perspective on kind of what we do and some of the stuff that we have in-house, we really specialize in really the three different avenues you can go with 3D printing, which is the plastics route, and then the kind of the more unique end of it, which is the composites and metals end. And we do have all the Markforged products in-house. So we have 3 X7s, 5 Mark IIs, and then the Metal X system as well, with all the materials available on that, as well as the Sinter 2 unit for volume sintering. And so I like to throw up some numbers on there as well to kind of hopefully give some people perspective of how quickly this industry is growing and how that adoption curve with this technology is really taking off, and we're kind of in a very unique state at the moment. So in 2019, we did just under 1,900 print jobs. So that's an actual file sent to an individual printer, and we did a little over 70,000 parts. And then here in 2020, we're just at pretty much the same cusp on the number of jobs sent. However, we've been able to kind of optimize a lot of the parts that we've done and some of the opportunities to get a lot more parts out of the same number of jobs sent. And so we've already scaled up the number of parts pretty significantly from the previous year, and we're looking to pretty much hit the double mark for the 2019 year, and a lot of people are pretty surprised to see volume that high with 3D printing, but to us that's still pretty small. We're going to be growing that out and continuing to fight the good fight in the additive space. So if you're tuning in today, you're likely at some point have asked yourself this question in your research for 3D printing, and it is not an easy question to answer, and it's which technology is the right one for you. This is probably the number one thing that we do at 3D Tech is answer this question for a lot of our customers. and especially early on in their 3D printing journey, they usually come to us and they don't just say, hey, I need this part, give me a price. It's, hey, I've got this unique application, or I've got this problem that I'm facing right now. Do you have a solution for me? And the answer in most scenarios is yes, but we really have to kind of understand the whole scope of it, because the image that you're seeing up here is really a overview of the entire 3D printing industry. So, you know, the media has done us a bit of a disservice in labeling 3D printing to mean one thing and, you know, one type of material and really one type of technology, but it's much more diverse than that. And so this kind of highlights the different companies that are involved in it, the number of companies, and really the different processes you can go to make a quote unquote 3D printed part. And, you know, probably the biggest thing to take away from that image is that each one is going to provide a part that is a good fit for a specific type of need and application. And the Markforged technology is no different. What I will say about the Markforged technology, though, is that it's incredibly unique, and there's pretty much 3 specific reasons why we decide to use Markforged over you know, all the other different type of FFF technologies that are out there. And it's because you know, yes, they are a 3D printing company, but really they specialize and have industry-leading materials, hardware, and software. You know, I've been fortunate to test out a lot of different types of nylon-based materials and different filaments, and from my experience, the Onyx material is by far the best. It's a nylon 6 with a chopped carbon fiber blended into it. Great for high temp environments as well as high impact environments and stuff that really is a good fit for, you know, machine shops and industrial settings, which is not really the case for most FFF type printers out there that are using things like PLA and ABS. So just off the bat, that the base materials are a big advantage for us and what we try to provide to our customers. The hardware on the systems is top notch, and it allows us to actually do stuff that you cannot do with other FFF style printers. That being the biggest aspect of it, which is embedding and routing fiber internally in composite parts. There's not another single printer on the market that can do it as well as Markforged and obtain the strength qualities that you really typically need for an industrial setting. And then software is a big component of this. Something that I would say is more often completely overlooked when evaluating a 3D printing in general. And the reason is because you know, if you've kind of been you know, on the machining side of things or injection molding, it doesn't play necessarily as such a large role in how well your part performs after it's been printed. So with the way the software technology works with Markforged, we can customize and completely tailor that part to what we need, meaning we're not overspending, we're not spending more time than we need to on the part. We can take what you see there, which is just a really basic kind of soft jaw fixture, and overnight have a part that performs just as well as an aluminum soft jaw as well. You know, I didn't have to pay an employee necessarily to go make that. I didn't have to take up machine time to go make that. All I had to do was, you know, throw it in the software, let it slice it, hit print, and I come back in the next morning and we can have that soft jaw ready to go. So, you know, from the perspective of a customer, you know, they can reach out to us and have next day tooling. But really the best customer that we have right now for the Markforged technology is ourselves. I use it all the time for some of our larger production opportunities and creating fixtures, kind of custom tooling, and all sorts of, you know, projects around the shop that we need things done right away. It's a great fit for it, and something that, you know, we're going to continue to keep having in-house. To touch a little bit more on, you know, some of the kind of the unique aspects of, you know, what you can do with the composite technology from Markforged, this kind of highlights that part that we were just looking at a bit more. And what you'll notice is that there's obviously, this is essentially an X-ray view or an internal view that you can get from the Eiger software. And what you'll notice is that towards the top of the part, there's a higher density of the yellow interior lines. And those are representing the ability to embed true fiberglass, high-strength, high-temp fiberglass, Kevlar, or carbon fiber in the part. In this case, this is high-strength, high-temp fiberglass. You'll notice it's mostly towards the top, which is because that's where I'm actually having my component grip onto the actual piece that I'm holding onto. And so I don't need to use an excessive amount of fiber at the bottom of my part. I mostly put it in there to just kind of reinforce the bottom sections. And then towards the top is where I'm actually getting equivalent strength to metal out of it using that fiber. And you can see that highlighted in kind of that bottom ticker bar, which has groupings of the fiber in there. And that's completely customizable. And I would highly recommend, if you get the opportunity, to schedule a meeting with Max so that he can run you through kind of how that works. It is pretty in-depth, so we'll be able to really cover it today, but it's something that's really, really cool and pretty unique. And I would say it's a good starting point for understanding the 3D printing technology and really how there are some differences within the market on things you can do from a software perspective. So, I love talking about the composites, but at the end of the day, everyone really is interested in the metal. So I wanted to give a little application spotlight on a D2 tool scale application that we recently built out, and our customer just went into production actually with these components. And really what you're looking at here are, best way to describe it, they're dent removers, kind of customized dent removers for hail damage. And this tool actually is used to go on the inside of a body panel. So if you had a dented door or something like that, you'd actually drill a small hole in the side of your door and use this tool to go in there. And the body shops can actually use it to finagle and kind of bump out that dent from the inside. Not an application that I ever knew about or even had any idea that it existed. But this customer reached out to us because they were trying to manufacture and get these small components CNC cut. However, the kind of specific surface that they needed with the spike features on the end of this made it pretty difficult to CNC. And when he first came to us, the part was actually not a really good fit for the technology. But with some minor redesigns, some tweaks and changes, we were able to get this into a space where it made sense for everyone involved. So I'm going to kind of run through actually more the design end of it and maybe highlight kind of where we can help a new customer down the path of additive, and hopefully kind of explain why there needs to be a bit of a shift in how you design parts and how you approach a technology like this. So taking a little closer look at this part, we call it internally just a little spike ball, best way to describe it. So taking a bit closer look at those spike features, it's a bit complex the closer you get. And to explain that complexity even a bit more, you might be asking yourself, why have those spikes designed the way that they are? Because if you notice, as they kind of go around the sphere and towards the bottom of the sphere, the angle, the bottom angle actually changes itself. And the reason is because we needed a way to make sure that there was no support that the printer needed to build underneath that. And the best way to describe it is if you break a 45-degree angle from the base plate that you're building this on, it's likely going to need support. So with a few minutes within our CAD system, we adjusted the bottom side angle of those spikes, and they no longer needed support. Cut down the overall amount of time needed to print this part, as well as the material needed. And again, just a minor change that had a big impact on it. But out of all the things we changed, that was probably the smallest bit of it. But looking at a cross-sectional view, you can kind of see that a bit more. And then also, when you look at the cross-sectional view, you realize there's a bit more going on the inside that you can't see from the outside. So to kind of highlight some of those features, you'll probably notice this cone internally. And this was not a feature that was in the part when the customer first came to us. But again, a few minutes in CAD, and we were able to get this built in. And so we used just a 55-degree angle internal cone. And the result was it completely eliminated the need for supports on the interior. And the result, again, cut down the print time as well as the material cost, but also just made it a heck of a lot easier to find this part and as a good fit for 3D printing. And then one of the other features that everyone loves to ask us about, or note or tell me that no, you can't do that. I get told that pretty regularly, that we cannot print threads right out of the printer. However, we do it, and we do it in scale, and we do it in volume, and we do it well, as kind of a proud piece of something we've been able to figure out. So we've incorporated the threads directly into it, meaning we cut down the overall kind of workflow needed for this part, as well as cutting down the post-processing needed. And the result is we don't have to get a lot of different people or workflows involved in the end-to-end process for this part. We can just take them directly from the sintering oven, go through our visual inspection, and then put these parts into production. And then, one of the last features that I think typically gets overlooked with 3D printing is the fact that, customization of your part does not increase the overall manufacturing cost at all. In this instance, we were able to incorporate the company's name directly onto the part, something that actually the customer really wanted, but didn't think that it would be possible. But it was, again, a few minutes in CAD, and we were able to have a pretty unique customized feature on this part that, they really enjoyed, and kind of moving forward is something that they're going to want to incorporate on all of their parts. So, it's something that I would highly recommend, using in parts that you design for 3D printing. And this can be implemented on composites as well. I'm sure Max has some applications and some parts that he can show you how you can use this in composites by actually debossing the text and then using just a wax crayon to be able to fill in that text. Works great for highlighting parts, putting product numbers on there, tooling IDs, whatever it might be. There's a lot of kind of mass customization that you can do with just additive in general, and more specifically with the Markforged product line. So to really drive this message home, and I guess kind of give you some hard numbers to work with, you might be asking yourself, well, why would I spend all that extra time to maybe redesign or optimize my part? Well, in doing so on our end, we took this customer from a hard no of, is this a good part for 3D printing, or can we do any sort of production, to a yes. And we did that, again, by changing some minor things on the part design, which overall cut the print time in half, as well as allowed us to get a lot more parts on an individual sinter run, and then resulted in roughly about a 30% cost reduction. And I would say that last figure there, the 30% cost reduction, is something we see pretty regularly when we get the opportunity to redesign a part for 3D printing. So that's really all I had for you today on giving you some stuff on our end. At this point, I'm going to pass it back off to Max here, and then I think maybe open it up to some questions.
Thanks, Pete. That's a really, really slick application. That's awesome. That's really cool. If somebody that's on the webinar with us this morning wants to engage with 3D Tech, would you recommend they go to your website and fill out the form, upload the STL, and so how does that process work with you guys?
Yeah, you're more than welcome to come to our website, and I do encourage it to really more kind of lean on some of the resources we have on our website. We try to put out some really good content and information about 3D printing, about what we have in house, and really how to best leverage us kind of in your process. But if you're interested in looking at a part, and if you're interested in reviewing a part, I would highly suggest reaching out to us, by phone, and maybe scheduling and setting up a time to sit down and talk about the part. We really like to engage with our customers and have a hands-on approach. So highly encourage it, and that's the way we found it kind of works best for our customer base.
Yeah, it sounds like, from talking to you today and just from my experience working with you and the other proprietors of Re3D Tech, is you guys like to partner with your customers. So there's the design for additive conversation. There's you've invited me and some other folks to your shop in Grays Lake, correct?
Yep.
Lake County, up here in Northern Illinois. And it's possible now, and even post-COVID, if you'd like to, I assume, to visit these guys, where if metal 3D printing, for example, was of interest, you can see the floor layout, where the gas is, the wash, the sinter oven, and how that's all put together. It sounds like there's a bay of Markforged printers, desktop and industrial. And again, the design for additive conversation can be had in more depth, and whether on the phone or in person. So.
Yep. And I will note, I know COVID is kind of putting a roadblock on some stuff, so our door is always open if you're interested in coming by and taking a look. But we can also give you a virtual tour, of our setup, and like Max said, kind of run you through all the hardware and everyday stuff needed to run a Markforged system. So feel free to reach out and be happy to engage in that with you.
Any point in the future, obviously, you're welcome to contact Re3D Tech, ask for Pete Kuchtra, or if you'd like to speak to me. I've spoken to a few of you that are online with us. Max Rockefeller at ShopWare. Pete, one of the questions I had on the metal side was materials. It sounds like D2 was what worked best for these guys, and obviously there's a certain hardness level that you get out of the sinter oven. What have you guys had any experience with any other metal materials?
Yeah, and we to give some perspective as well, deal with all kind of metal printing technologies that are out there, and we really enjoy working with the Markforged technology because they offer some materials that you just can't get on any other platforms. So the D2 is one of those materials. So it's great for high hardness applications, but really a best fit for high wear applications, something where it's really going to be used in continuous cyclical application. And the spike ball is a good example of that. H13 is another material that has a lot of interest, kind of on the molding side of things, and we've played around with that a little bit. And are kind of growing out that application space. A2 is another one that is a bit tricky to find as a 3D printing material, but is a really good material that processes well on the Markforged. And then probably the most unique material of the bunch is the copper. We've started building out some very customized applications using that material, specifically kind of little custom bus bars and stuff actually used in electrical components. There was some concerns or worries about how well it would work for electrical conductivity, but some of our really big name customers did internal testing, and the results were very, very promising. And we've done some repeat business on that, and I'm pretty excited to kind of grow out some of those applications as well.
One question I see here coming in is about heat set inserts and the ability to perhaps to print around a bushing of sorts. You guys have experience with with heat set inserts and putting screws, or pardon me, putting threads in the composite parts with that fashion?
Yeah, and that's a great question. That's something that we get asked on pretty much on a daily basis. Is can I, just build threads into my part? Now, obviously, we showed you that you can do that with the metal application, but when it comes to composites, and if I'm looking at replacing a metal component with a plastic or a composite component, you typically don't want to thread directly into the plastic if you're hoping to get part strength equivalent to a metal. So what we can do is actually design a cavity in the composite part, and then after it's been printed, use a heat set insert. And the way that works is it's pretty much you can get them in steel, brass, or aluminum. They're just kind of an exterior knurled little insert that you can pop in, and using essentially a soldering iron, actually install those in so they're locked in there very, very good. And we can reinforce kind of the exterior of that cavity using fiber again, so that you're getting a metal thread in a composite or a plastic part. And I have a lot of data and information I can share on the torque out strength and the pull out strength for a lot of these, because most people don't actually believe me when I tell them the numbers that are achievable with it. And it's a service that we actually offer pretty much at no cost other than the cost of the insert. And actually the tool and piece that we use to install them was all built and designed using Markforged components. So we have a little custom install tool that I think highlights some of the uniqueness that you can do with this technology.
Great. No, I appreciate that. Good. We appreciate you spending time and allowing us to share this information with you. Well, again, thank you for joining us, Pete and Matt. Thank you for your role in making this a successful webinar. And take care, be safe, and we'll be in touch soon. Thanks, everybody.
Thank you, everyone.
Thanks, Max.